I'm Anil Kumar and this is my test question for your trigonometry test. Solve the equation tan x plus 3 cotangent at x equals to 5 times secant x, where x is between 0 to 2 pi. Now to solve such question, we should actually write all these terms in terms of sine and cosine. So let's begin by writing sine x over cos x for tan x, right? Plus 3 times cotangent is cos x over sine x, and on the right side we have 5 times secant is 1 over cos x. The domain is between 0 to 2 pi. Now what we can do is we can get rid of the denominator by multiplying each and every term with sine x cosine x, right? So if I do that, so we are doing times sine x cosine x, all the terms, correct? So that is what we are doing at this stage. So the first term, cos x cancels out, we get sine square x, plus 3 times sine x cancels out, we get cos square x, and here we get 5 times cos x cancels out, we get 5 sine x, correct? So that is what we get in our equation. Now we have sine square sine x. Cos square could be written in terms of sine, so we'll have quadratic equation in sine, right? So bringing this on the left side, we get sine square x, that is the first term, plus 3 times cos square x is 1 minus sine square x, and minus 5 sine x equals to 0. So let us expand this. We have sine square x plus 3 minus 3 sine square x minus 5 sine x equals to 0, right? So we have used here the identity, which is cos square x plus sine square x equals to 1, and therefore cos square x is 1 minus sine square x, correct? Let's combine these terms. We get minus 2 sine square x minus 5 sine x plus 3 equals to 0. It's good to write these numbers with positive, so I'm just multiplying everything by minus 1. So we get 2 sine square x plus 5 sine x minus 3 equals to 0. Now we need to factor it. So 2 times 3 is 6. We need minus 6 and sum of 5. So we can write 5 as 6 and 1, right? So we could write this as 2 sine square x plus 6x, plus 6 sine x minus sine x minus 3 equals to 0. Taking 2 sine x common, we are left with sine x plus 3. Here we can take minus common, we get sine x plus 3 equals to 0. Now let's move to the right side and solve it further. We could actually go in further. We can take sine x plus 3 common, so we are left with 2 sine x. I hope you can see this, okay? Minus 1 equals to 0. So that is the factored form. Now we need solutions of this in the domain 0 to 2 pi. Let us write down both our factors and analyze. So we need sine x plus 3 equals to 0, or 2 sine x minus 1 equals to 0. Now from the first factor, what do we get? We get sine x equals to minus 3. Well, that is not valid, right? Not valid. You know, range of sine is between plus minus 1, so that is not valid solution. The other one, we get 2 sine x equals to 1, or sine x equals to half. So that is a valid solution. Sine x is half. The domain is 0 to 2 pi. So we are looking for solutions in quadrant 1 and 2, since sine is positive. You know the cast rule, right? So when is sine x half? You could actually use special triangles, right? Or you could use your calculator anyway. So we have two possible solutions. Let's use the special triangle, which is 60, 30, 90, right? So in that special triangle, you know, the sides are 1, 2, and square root of 3, and this angle, sine is half, this over that, pi by 6. So we have acute angle, which is pi by 6 for us. Correct. So we have pi by 6 as one solution. And the other one is acute angle of pi by 6 will give us 5 pi by 6. So we have two solutions here. So we can write x is equals to pi by 6 or 5 pi by 6. So these are the two solutions for the given equation, right? So that is our answer. So x equals to pi by 6 and 5 pi by 6. So that is how we can solve such questions. Now the key idea here is whenever you have secondary trigonometric ratios, write them in terms of sine and cosine. It becomes simpler and then solve it. I hope that helps. Thank you and all the best.